Hi everybody! So today's video is going to be about Module 2, Task 7, which is Task 2.7. And our target for today is going to be, I can graph a linear function given an equation, a table, or a situation in context. In our previous video, we were really looking at writing the equations of linear functions. Now we're going to kind of go the other way, and I'm going to give you some information and ask you to find the graph or create the graph. So the first scenario says Johnny has $25 in his bank. He saves an additional $15 per week. First, we want to make a table. So based on the scenario, I can see that the starting value would be 25 because he's already got that much. Then it says he saves an additional $15 per week. So to get the next value, I would add 15, which gives me 40. To get the next value, I would add 15, which gives me 55. For the next one, I would add 15, which gives me 70. And finally, I would add 15, which gives me 85. Then I can make my graph by graphing these points. So 0, 25. 1, 40, 2, 55, 3, 70, and 4, 85. Now I need to also label, so the outputs of my table are money, and the y-axis of my graph would be money, and the inputs on my table are weeks, so the x-axis would be week. Now, the last thing I need to decide is, should I connect the dots here or not? Now, money is not something I'm going to measure. I'm not going to measure it with a ruler. I'm not going to pour it into a cup and measure it with a measuring cup. So I am not going to connect the dots because money is something you count. You count your money. You don't measure your money. Okay. Now that's how we've always graphed these things before. But now what we're going to be doing is I'm going to give you an equation and no other information, and your job is to figure out how to make the graph. And we're going to do this by doing something called identifying the key features in the equation. So in this equation, there are certain pieces of information that we can pick out that then we can use to create a graph. And those pieces of information are going to be the starting point and the slope. Now, the starting point has two pieces. A starting point needs an x and it needs a y. That's what you need in order to have a point. Now, if we look at this equation, I can find the x for the starting point by looking by the x in the equation and asking myself, how do you get back to 0? Just like when we write equations, we always want our x to get back to 0. This is the same idea. How do you get back to 0? If this says x plus 1, then to get back to 0, we would just use minus 1. To find the starting y value, I would just look at the starting value of the equation. So my starting y value here would be 5. Now, normally that is written at the beginning of the equation. However, the other thing you can think is that that's always the number that is not attached to the x or the parentheses. Finally, we need a slope, and the slope is always the number that's multiplied by x. So in this case, it's multiplied by x on the outside of the parentheses, so my slope would be -2. Now, when it comes to graphing, it's going to be much easier to graph that if you make it -2/1. So that is my recommendation, is that you turn that into -2/1 to make the graphing a little bit easier. Now, for the second problem here, we have a different type of equation. We have what's called slope-intercept form. I can tell that it's slope-intercept form because there's no parentheses in the equation, and if there's no parentheses in the equation, it's got to be slope-intercept form. So our starting point is still going to have an x and a y, and our slope is still going to be the number that's multiplied by x. Now to find the x here, we look by the x, and we ask ourselves, how do you get back to 0? Well, since there's no parentheses here, it tells me that the x was already 0. We didn't need to adjust. It was already 0, so we didn't need to add or subtract anything. The y is still our starting value, or in other words, the value that isn't being multiplied by x. And our slope is the value that is being multiplied by x. In this case, -2. And I would suggest that you write that as -2/1 because that's going to make your life a lot easier when you go to graph this. Now that we kind of know where to find our starting point and our slope, let's try a few practice problems. So for problem number 1, step 1 is going to be to find the starting point and the slope. Now our starting point here is going to need an x and a y. The x is going to be whatever it takes to get back to 0. So to get back to 0 here, you would need +1. The y is going to be the beginning number, which in this case is 4. And the slope is going to be the number that's multiplied by x, which in this case is +3, and I'm going to suggest you put that as 3/1. Now we did these problems the other day, we just didn't start with the equation. Once you have your starting point, you can just graph it, the point 1, 4. And then from there, you can do rise over run. So rise 3, run 1. Rise 3, run 1. If you run out of room, you can always go backwards. Down 3, left 1. Down 3, left 1. Down 3, left 1. Down 3, left 1. And then you can connect your dots by just drawing a nice straight line. Now you do want to make sure that you use a straight edge here, and you want to make sure you put arrows on your graph. For problem number 2, and I should circle this. This was the starting point of the graph. That was the 1, 4 that we started at. For problem number 2, this equation looks a little bit different because there's no parentheses. And what that tells me is that we did not need to adjust the x at all to get back to 0. So the x was already a 0 for the starting point. The starting y would be the 8, which is not being multiplied by x. It's kind of separate by itself. Next, we're going to need the slope. The slope is always the number that is being multiplied by x. In this case, -1/2. Now, a lot of students struggle with this because they say, is the 1 negative, is the 2 negative, or are they both negative? And the answer is, you could pick one. It could be the 1 is negative, it could be the 2 is negative, but you cannot have both be negative. So for problem number 2, we would start by graphing our starting point, which is 0, 8. That means don't go to the left or right at all, just go up 8. 1, 2, 3, 4, 5, 6, 7, 8. From there, you're going to go down 1/2, down 1/2, down 1/2, down 1/2 until you run out of room. And then you're just going to draw a nice straight line through those dots with arrows at the end. Okay, for problem number 3, we need a starting point and we need a slope. So our starting point is going to have an x and a y, and our slope is going to be the number that's multiplied by x. In this case, our x is actually written at the beginning, but that's okay. There's no parentheses, which means we didn't need to adjust the x at all. So it means this is a 0. And the starting y value is going to be the number that's not multiplied by x. In this case, that would be -5. The slope would be the number that is multiplied by x, in this case a +2, and I would suggest writing that as 2/1 because I do think that will make graphing a little bit easier. Now our starting point is going to be the first thing that we graph, so 0, -5 puts me right here. From there, I'm going to go up 2/1, up 2/1, up 2/1 because my slope is 2/1. You could also go down 2, left 1, down 2, left 1. And then you can just draw your nice straight line through those points and make sure that you put arrows at the end. Last but not least, again, this equation looks a little bit different. They just rearranged the way that we normally write it, and they put the starting value at the end this time instead of the beginning. But that's okay, we can handle it. When we look by the x, we have to ask ourselves, how would you get back to 0? Since this is a +2, we would start with -2. And our starting output would be 5, which is the number that's not being multiplied or added to the x. Our slope would be the number that is being multiplied by x, in this case, -1/3. Our starting point is the first thing that we're going to graph. So we're going to graph -2, 5. And from there, we're going to go down 1, right 3, down 1, right 3, down 1, right 3. Now, just like before, you could also go up 1, left 3, up 1, left 3 if you wanted to make the 3 negative instead of the 1. The only thing you can't do is make them both negative. So either the 1 or the 3, but not both, can be negative. And then that's my line with my arrows at the end. Now, the last thing we need to do today is figure out whether two linear equations are equivalent or not in a couple different ways. So, equivalent is another word for equal. Our goal right now is going to be to determine whether two linear equations are equal by graphing. So, let's make a graph that has the points from each of the following tables. Use a different color for each table. I'm going to graph the first table in pink. So for the points that are part of this table, I'm going to graph -2, 6, that's right here, -1, 4, 0, 2, 1, 0, 2, -2. For the points in the next table, I'm going to make them green. So 0, 2, same point as this one, 1, 0, same one as this one, 2, -2, and then 3, -4, 4, -6 are new. Now, what do we notice about the points from these two tables when we make a graph? Well, what I notice is that when you look at them all together, they make a straight line. And the reason that that's important is that if all of the points all together make a perfectly straight line, then that means the tables represent equivalent equations. So because they make a straight line, the tables must represent equivalent equations. It means if you wrote the equation, even though that they might look different, they represent the same information. Now, what if we don't have a graph? Just like we can tell that two linear functions are equivalent if their points are all on the same line, we can tell if two linear functions are equivalent by rearranging their equations to see if they're the same. We do this by distributing and combining like terms. So, for this first problem, we've got equation number 1 is this guy, and equation number 2 is this guy. And we want to see if they're secretly the same equation, just in disguise. What you're going to want to do is take the more complicated equation, which is always going to be the one with the parentheses, and you're going to want to rearrange it. So the way we're going to do that is we're going to start by copying it down without changing anything. So just drop it like it's hot. Then we're going to distribute. Now, we practiced distributing before, and it's coming back. So the reason we learned it the other day is so we could use it for this. If we distribute, we get 3x minus 21, and we're not going to change anything else. So just drop it like it's hot. Copy down the rest without changing anything. Then you're going to combine like terms. In this problem, the -21 and the +25 are like terms. Then when you combine those, you get +4. For the rest of the equation, you're just going to drop it like it's hot, and you get 3x. If you look at this final simplified equation and you compare it to the other equation that we didn't rearrange, you'll notice they're exactly the same. What that means is that these two equations are equivalent. Now for the next problem, you'll notice that we have the same idea. We have two equations. We're going to start with the more complicated equation. So the first step here was to distribute. I should probably make a note. And then the second step here is to combine like terms. Now, the more complicated equation this time is going to be the first equation. So we're going to start by copying that equation down. Don't change anything. Y equals 2 parentheses x minus 4 plus 6. And now we're going to distribute just like we did before. So we have 2x minus 8. Copy down the rest of the equation. Don't change anything. Just drop it like it's hot. And then combine like terms. So negative 8 plus 6 makes negative 2. And drop down the rest of the equation. Just drop it like it's hot. Now, if we compare this equation to the equation number 2, they're not the same. So that would tell us that these equations are not equivalent. All right, that's it for today. Thank you guys so much for watching, and I'll see you soon for some practice.